நீங்க வா ಹೋಯ್ತು ಮಂಗ ಎತ್ತದ್ನ ಅಲ್ಲೆಲ್ಲ ಐತೆ ಅದೊಳಗೆ ಸಂಜೆ ಒಳಗೆ ಯಾಕೆ ಹೋಗಿದ್ವಿ
pattern. Praveen, can you hear me? Yes, you are. Okay, sure. So there will not be any feedback in the Teams, right? Hello? Good evening, everyone. I hope you had a, a great day today, and then you are attending my talk today. So, as introduced by Dr. Praveen, I work with ICU Medical, which is a medical device manufacturing company, and I head the cybersecurity team in ICU Medical. So today's talk will be on cybersecurity in healthcare industry. So I'll be drilling into cybersecurity. What exactly is cybersecurity and the requirement for cybersecurity in medical device field, right? And also I'll also touch upon a little bit of experience, my experience in medical record management and security issues related to medical records management. So what is cybersecurity? So this is actually the definition which is given by the US National Cybersecurity Council. So cybersecurity is considered to be a field which provides confidentiality, availability, and integrity. These are the three main things which are provided by cybersecurity: confidentiality, integrity, and availability. And these are provided to information systems. So information system is a group of things like, for example, the people who actually operate on some data, and the software which operates the data, and the hardware which actually runs the software on it, and also the processes which actually bring these things together, which is called as information systems. So confidentiality, integrity, and availability of information systems on top of any type of attacks or accidents or failures of the system, and protecting the operations and assets. So basically we consider cloud storage, digital media, websites, anything, right? Anything can be considered as assets, which actually has some value for the business. So what we do is, like, basically cybersecurity is the field which actually offers various tools and techniques to provide security, that is the confidentiality, integrity, and availability of these digital assets. So, when you talk about cybersecurity, we also have to talk about cyber attacks. So, what comes to your mind when we hear the word cyber attack? So when I was young, I used to think a hacker or a cyber attacker is a person who wears a hoodie and then he works in a dark room and then he has a lot of computer and he has a lot of internet access and he knows everything in and out in a computer or a connected world, right? So basically, this comes to my anyone's mind will actually think about a person with a hoodie, but that is not the case. Like when we started watching films, which actually has attackers and hackers. So the first time when I saw this movie. Golden Eye in 1995. I saw this person. There was a single person who was operating a lot of computers in and around a room, and then he was actually trying to break into a nuclear system. Right. So the asset here was like a nuclear system. So 1995, the comprehension of asset was a huge system which was actually considered to be very, very secure, and no one can actually enter into a nuclear systems network. Right. So slowly the paradigm has shifted now. So last year I watched a movie which is called as Beekeeper, and here the paradigm is totally shifted. So there is no one person working here. This is like a group of people who are working. Are no longer very, very high valued assets. So the hackers are like interested in hacking small things, and then if someone actually tries to break into a nuclear system, the penalty for that will be very huge. But then if someone is trying to attack your or like hack into your bank account, the penalty is not so high, right? So you'll not be penalized to death or something like that for breaking into a bank account. So the hackers have evolved in such a way that they actually consider even small assets to be valuable, and this is actually to show the paradigm shift in terms of assets. So there are few news which actually came to my mind when I wanted to talk about this thing. So this was actually a news in October 2022, where we see that Indian workers rescued from digital job scams in Southeast Asia. So people were hired for doing some IT works like software development and stuffs like that. But after reaching to countries like Myanmar, Laos, and Cambodia, they were actually asked to scam people, right? So they were asked to work in groups which actually try to contact people and then do some social engineering and try to break into their bank accounts. So these type of frauds have started evolving. And you should also know that the trend for cybersecurity attacks is like very it's like $1 billion industry now. So you can see this is one example of ransomware. So where the global ransomware damage cost is being predicted to be $275 billion in 2031. So this is actually the news in April 2025. So you could see like what's the scale of this. This is one single attack, ransomware attack, and even today I saw like a couple of ransomware news. One of them is in a pharmacy industry, and the other one is like in a development company. Right. So ransomware is like a huge market for software attackers, and this is also a trend these days. And moving on to the latest trends, like you could see like 87 percentage of this is actually a news by Digit News. You can see like 87 percentage of firms these days have been hit by AI cyber attacks. So what is this AI cyber attack? So typically what happened is like people do it manually, right? So you need to find out an open port in a system and then see if a port is open, and then you try to see whether there is a vulnerable piece of code running there, and then try to insert a piece of code and execute your malicious code inside a system. So now this was done manually long back, and even like very recently people were doing it only manually. But now with the help of the improvements in LLMs and stuff like that, you would be able to generate automated request and automated scanning, port scanning, and then see whether some of the vulnerabilities can attack, and these things can be automated in an effective way. So it seems like going forward, most of these cyber attacks will be powered by AI. Now the next question is like, who carries out these cyber attacks, right? So basically there are two different types of hackers. One of them are like spies, and the other one is like hackers themselves. So what does spy do, right? Spies actually work for companies, or they also work for different countries, and they try to get the information about a different company or a different country, right? um, and what actually is interesting is like military secrets, right? So spies are like almost we consider them as like ethical, and then they actually work for national interest. So basically military secrets are the main um, assets for them. And information on advanced research is also available for these spies, right? So the raw wing is a lot of information about the cybersecurity attacks which are happening, and then they actually try to prevent a lot of vulnerabilities or like attacks which are being targeted towards our critical infrastructure. So the other thing is like spies, they don't worry about any hardship. They actually even uh, hackers don't try to do that, and they wanted to do it in a lesser time than spending a lot of time over the effort. So they also attack with a very little effort. They don't try to pump in a lot of energy, like taking the help of supercomputers and stuff like that, but rather they try to get access to small mobile phones, like we would have heard about bots, right? So they actually try to make use of a lot of mobile phones which are like very very small in computation power, then club together to get a great power from that. So, what type of tools the cyber attackers use? So, these are like very, very standard tools, or like softwares, or like techniques which they use. So, first one is like malicious bots, which we may know. Like most of the time, we see some unwanted exe running in our Windows operating system. So long back we used to see like in Windows 95 98 days we used to see a lot of exes automatically being executed in our computers. But then later we understand that these are like not intended to be run by us or the operating system. So we evolved with malware, anti virus softwares and stuffs like that. So malicious bots are used for um, extracting the computation power from any computing device, right? And ransomware is like the we'll dive deep into ransomware, and keyloggers are used for identifying what key is being pressed in your computers or laptop. These are like malware types of malwares, right? So these are like extensions of malwares with different purposes. And phishing is like very standard. We all know about phishing nowadays, sending malicious emails and then getting information from that. Social engineering, it's a group of attacks. Like there is no specific way in which you have to do social engineering. You can gather information of a person, try to spoof the person social media. You can actually try to spoof a person in WhatsApp, and then try to extract information or money from the friend list or contact list or anything from you, and then try to make use of the information they have gathered to attack and or like to fool someone around, right? So these are like some examples. Suddenly on seeing something, they just wanted to install some apks, and they install it, and then they don't know what is happening on the background, right? So some games and some video sites which we download and then we install in our mobile phones, they actually try to exhaust your memory by running crypto minings, or like any other hard complex computations will be run on the background. So these type of bots will be used for performing mining operations and DDoS attacks. And ransomware is like very interesting these days. Like we see, so the whole network, right? So even if you like have antivirus, you have so many things. You have a proper firewall. You have updated the patch and everything. Ransomware is like very easy to be installed if there is one small gap in the system. So let us consider an organization which has a lot of employees, and one employee has kept his default password for his email, right? Or he has kept a default, or like he has kept a weak password for his network access or something like that. So someone who gets access to the network or the computer on which this person is logging in, or the laptop which he uses for logging in into the system, they can actually enter the system and then try to execute in a oblivious way, so that no one can understand this is the key for the decryption. Once all the systems are logged out and they are encrypted, now there is no other way, so the network administrator will be prompted to pay bitcoins, or like he'll be asked to pay some real currencies, and then to get the decryption key, right? So most of the time these keys may not work, because these they are not like professional people, right? So they are hackers. They just try to encrypt it, and then if they lose the key, or like if somehow the key is crashed, then they don't know what the key is, and then the data is lost. So this brings out a lot of business related downfall for a lot of big businesses. So the only way to come out of this situation without paying the ransom is to have proper backups and stuff like that. So these are like very important cyber attacks these days, and I'll just skip through this, and then yeah. So we have seen about cybersecurity now. What cybersecurity is about? It's about protecting critical infrastructure. It is about protecting the assets of a system or an information system, whatever, right? So how to protect, or how to provide confidentiality, integrity, and availability for our assets. Maybe digital, or it might also be like physical assets, like hard disk and stuff like that. So where does this apply? So cybersecurity applies to all fields, whatever you say, right? So in any kind of business software, you call it as corporate security, or if it is like for web applications, we call it as web application security, and then installed APKs, we call it as mobile security. So mobile security does not consider APK security alone. It also considers about the operating system which runs on the mobile phone, and all other things which are related to mobile phones, right? So in embedded systems, if you are trying to offer security, then you call it as embedded security, and so on, network security and IoT security. So basically different systems need different type of security measures for different type of issues, right? So it is not like a silver bullet which can solve all the cyber security issues in all the systems. So this talk will be about medical devices and healthcare systems. So basically, these are like the standards which we use for cybersecurity, to manage cybersecurity in systems, right? So OWASP Top 10 Web Application Security is actually a list of top 10 vulnerabilities which are prevailing in the web application systems. And for mobile security, we have like a top 10 mobile OWASP top 10 mobile list. And for embedded systems, we have embedded app security top 10, and so on. API, we have API security risk. And for IoTs, we have IoT security risk. So each of this is like the top 10 vulnerabilities. So how do we come up with this top 10 is a very interesting thing to know, right? So there is something called as the National Vulnerability Database, which is maintained by the US government. And this National Vulnerability Database is sourced with a lot of vulnerabilities which occur on open source software, and also products, right? On hardware products or software products or anything. If someone in the world finds out a vulnerability in Windows, they immediately submit it to National Vulnerability Database. The MITRE actually is the people who are actually managing the National Vulnerability Database. So what they do is like they identify whether this vulnerability exists, and then they publish with a unique identification number, which is called as the CVE number, Common Vulnerabilities and Exposure Number. Now, in a year, or like this list is actually curated like once in 2 years, 3 years, or 4 years, whenever it is needed. So what they do is like they try to find out the vulnerabilities which are present in the web applications. So for OWASP top 10 list, what they do is like they collect all the vulnerabilities which are related to web applications. And what they do is like they classify them based on common weaknesses enumeration number, CWE number. So a common weakness enumeration number might be like remote code execution error, right? Or null pointer reference error, or double free error. So these are like common software errors which can actually lead to a security issue in a system. So what people do is like they actually relate the CVEs to common weaknesses enumeration number, CWEs, and they make a huge list of these vulnerabilities. And now they categorize, or like they take the count of the CWEs. So the maximum number of CWEs which are reported for web applications will be in the top first category of OWASP top 10 list, right? So in the same way they do for mobile applications, they do for embedded systems, APIs, IoTs, and so on. So this is actually the list of top 10 vulnerabilities for web applications, which was published in 2021, and we are waiting for the next release. It might happen soon, but that time this list will be like having some modifications or changes. So first thing is like broken access control, and any kind of access control related weaknesses in the system will be related to this first category. The second category is like cryptographic failures, where you understand like the implementation of some cryptographic systems might lead to a vulnerability, or like it might lead to a security issue. So the cryptographic failures will be listed under the second. So this seems to be the second highest number of CWEs present in the year 2021 for web applications. So someone would have used a wrong pseudo number, random number implementation, or someone would have used a wrong RSA implementation, and so on, right? So these type of issues will be captured under this. And all kind of injection comes under A3, which is like SQL injection is one of the attacks. Command injection is another type of attack. And also we would see like cross-site scripting injection. That is also a kind of injection into the script, right? So basically there are a lot of injection type of vulnerabilities which can actually be done on web applications. And this injection is a representation of all these kind of injection errors. And so on. You could see like insecure design, security misconfiguration, vulnerability, and outdated components. So basically, if you're using an outdated open source software which is not being supported, and then that will also be listed as a CWE, which is like sixth largest number of CWEs in 2021. And so on, right? So there are like a lot of these vulnerabilities, set of vulnerabilities, which is being clubbed together, and then this actually forms a top 10 list. So any vulnerability which is identified and in this category in your system will be having a very high priority to be triaged and then to be done, right? It has to be fixed immediately if it is in the top 10 list. So this is one of the recommendations and standard for web application. And then the same way we have it for mobile application, we have a 10 different type of items here. So here you could see like security misconfiguration is common to OWASP top 10 as well as mobile top 10, right? And same way you could see like for this is for the embedded application standards. So here also you could see somewhere there will be a misconfiguration, and this is actually for top 10 API security risks. So here also you could see like security misconfiguration. So security misconfiguration is a common thing which actually is present in all these OWASP standards. So typically what accounts for security misconfiguration is like the system might be very, very secure, but then you configure it in a wrong way so that the wrong people can enter the system. All right. So security misconfiguration, one of the examples are like very widely spoken example for security misconfiguration is the use of a weak password or like a default password in the system, right? So every system, every information system comes in with a um, default password. So the first time when you want to use a system, you need to actually punch in a default password, and people don't actually change it, right? So the modems in our home will come with a default password. The ATAL modem or like the Geo modem comes in with a default password, and the person who comes to install it, if he does not ask you to change the password, it will be having the default password 12345 6 or something like that, right? Which is very easy to guess. And then most of our routers will be open, and someone wants to configure the router, they can easily access your router by just punching in this password. That's it, it's straightforward, right? So security misconfiguration is like there will be a lot of configuration in the system, but you need to actually configure it in the right way to make it secure, right? So there will be TLS enabled in the system, and then by default you will not be enabling TLS. So if you have the default configuration and then running in the real time, TLS will not be enabled. So any man in the middle attack can happen in your system, right? So these are called as like security misconfiguration. So there are mitigations for these type of security misconfigurations, where you ask the first time login to change the password. The default password has to be changed when you log in the first time into the system. So these are some techniques to avoid these type of attacks. So I just wanted to brush up or like just show these things, which is like the top 10 in various categories for information systems. So having known about cybersecurity now, and there are standards. So this is like only a handful of standards which I have shown you. There are other standards which also might be applicable for security. Like FDA has their own cybersecurity guidance for medical devices, and they have their own standards for various cybersecurity related issues, right? So based on their guidelines, we need to build the system, and we need to actually test the system so that the system actually adheres to the guidance is provided by FDA. So this is one requirement for medical devices which are being sold in the US, and other countries have their own regulations. Like India has FDA, and also it also has FSSAI for food standards and so on, right? So the same way for medical devices, we also have our own standards, and then we need to follow them if you want to sell the devices in India. So the next thing which I wanted to bring out is like the other thing which electronic health systems, right? So electronic health services systems, we consider electronic health records as the key for electronic health, the digital health systems, right? So basically what happens is, like previously when we used to go to the hospital, there will be a case sheet which is written on a paper, and then the nurse or the receptionist of the hospital will be writing our name, the doctor's name, our age, and all the health condition in the prescription, and then it will be stored in a file, in a physical format. And what happened is like this file is not transferable. So you go to a hospital and this file cannot be used in a different hospital to show to the to another physician or like a different hospital. Right. So in order to actually facilitate this, what happened is like people started working on electronic health records and electronic patient records, which actually has a person's healthcare information from cradle to grave. So a person is born, and then a baby is born, and then the baby's details are being stored, and then this detail will be actually slowly getting added up with other details of his or her physical and health related information. So this is actually called as the electronic health record. So anything you, as you see in this diagram, you can see like patient personal data can be anything like pharmacy and medication information. So you get a prescription in your name, and that will be one of the data for you. Social services like blood donation and stuffs like that, plasma donation, and if you do any of these, that will also add to your health record. screening and vaccines. So what vaccines you have taken, right? So the COVID vaccine, which we can actually download as a currently we can actually download it from Umang's site, and then you can actually provide it as a proof to people, right? So and the same way, like anything, like you go to any hospital, lab results, diagnostic images, and any medical data will be considered as electronic health records. And electronic health records which are specific to a patient is called as electronic patient record, and this actually is the core for paperless hospitals. So basically we end up saving a lot of paper using this EHR systems. So a lot of security related issues happen in EHR systems. So there was a research paper, and this is actually a key paper which categorizes or like characterizes the privacy and security requirements for EHR systems, right? So the first thing which they did was like they categorized into what are the requirements, or like what are the places where we need cybersecurity or security and privacy for EHR systems. The first thing is like architecture, and based on the architecture we have like distributed and cloud systems. And for access control, what are the different ways to provide access control for EHR systems? They came up with role-based access control, identity-based, and attribute-based systems. And how do you get emergency access to the data? So for that, they have identified few techniques. And for sharing of information, how to share the EHR system to a different hospital, to a different doctor or physician, whatever. So how to share the information among people, and how to search on encrypted EMR systems, right? So so these are the classifications which actually talks about a lot of privacy and security related things. So in order to achieve these things, we need a lot of cryptographic protocols, and we'll see one by one going forward. So based on the architecture, what happens is like this is actually for distributed architecture. So the healthcare data is mostly distributed. We go to different hospitals, and then we have different information in different hospitals which are being stored, and then we use it for different purposes. So the EHS system is stored in multiple institutions. This architecture is like distributed architecture works very well because we can access the medical data from one hospital from a different hospital, right? So here the key point is like trust management and trust negotiation. So if you want to actually access the medical records from one hospital, it has to be sent from it has to be approved, right? So the data is actually present in one hospital, and their different hospital request for your health record from the other hospital, it has to be approved. And the first thing is like it has to be managed. Like we have to trust, like the hospital one has to trust the hospital two, and then trust management has become a very important point here. And how to negotiate trust, like you need to say that okay, I need access to only this person's information, and specific to his illness from this date to this date, right? So how to negotiate on the trust, and then who actually can access this data? So all these things can be achieved using cryptographic primitives, and they are actually implementing it using TLS communication here. So here, if you see, this is actually a distributed architecture where your data is actually present in the EPR systems, which is actually present in various hospitals, which is encrypted. So all this data is like encrypted, and there are a group of people who are associated with each of these hospitals. So these people, this set of patients will have their records in this system, and so on. So different groups will have their records in the different hospitals. So now what happens is like in India, we see this, right? So if you go to Apollo, you'll have a different EPR system where they have their own database, and they keep the data themselves. And if you go to Kaveri Hospital, you will have a different set of. And if you go to Fortis, they have their own setup, and they have their own EHR system. So it is not interoperable, right? So one system cannot, like the one data data from one hospital cannot be actually easily shifted to a different hospital because they have their own EHR systems, and then the formats even don't match, right? So let us consider a scenario where this patient who is affiliated to hospital 1, for some reasons he had to go to hospital 3. So what he has to do is like he has to make a request. So we need a central server so that these hospitals are affiliated to a central server, and only then the data can be easily exchanged with trust and trust negotiation, right? So the hospital management has to log in into the main server, and now the server actually recognizes this person, this hospital, because it is a TLS communication. There are certificates being enabled. There is a root certificate which actually certifies the public keys of both these entities, and so the same way, hospital 1 is also a trusted entity to the main server. So what happens is like there is a mutual communication channel established between these two hospitals now. Now there should be a trust negotiation, which reports have to come to this hospital and which reports needs to be screened from this hospital. So all these things can be achieved using cryptographic primitives uh, for negotiating trust. So the EMR system over the cloud, you see, like it comes with all the advantages of the cloud model. So as we all know, like we have public cloud model, we have private cloud models, we have hybrid cloud models, we have community cloud, and so on. So the advantage of using this cloud model is like it is very, very cost effective, and you pay per use, right? So you don't actually have to own the hardware, or like you don't have to run it all the time. Only as per use you will be paying for the services. And it is also like it provides stability, scalability. You can actually include a lot of hospitals in your chain, and then you can actually go ahead, and then it is scalable. And these are the inherent properties of like using the cloud infrastructure. But there are like cybersecurity or security issues when you go to the cloud. So what we do here is like this is the cloud service provider, and the cloud service provider is the person who actually offers you the storage, or it actually offers you the computing power for performing your operations, right? So Amazon's EC2 instance, or like Azure by Microsoft, all these are like cloud service providers. They provide a lot of computing power and storage for you, so that you can actually run your applications in the cloud and store the data in the cloud, and use it as and when it is required. So the cloud service providers are like classified into three different categories. The first one is like trusted CSP. So as you see, like it is like fully trusted service provider, and you understand that you have a service level agreement. You just sign that, and then you fully trust the CSP, right? So when you say like I trust a CSP, what happens is like they are legally bound. So you have some legal agreements made with the cloud service provider, and if your data is being leaked somewhere, and you have the proof that your data is leaked, you can actually bring them into the federal court, right? So you can it is legally bound. The service level agreement is like legally bound, and then you can as a user, you can anytime sue the cloud service provider for any miscreant actions. So the trusted CSP never gets any information about the stored data. So this is what we understand from trusted CSP. Whereas this is the semi-trusted CSP. So this is a honest but curious server. So Google might actually store all your information, but it is not going to leak your information, but it is actually using it for some sort of data analytics, right? So what kind of data you are interested in, they wanted to understand. So they use your data, and but they don't leak your data, right? And even Facebook or any other social media sites, they don't actually sell your data, or they don't actually sell it in raw, basically. They use the data. They are curious to know what you are doing, but they don't actually leak your data anywhere. So they come under this semi-trusted CSP category, and they actually follow the protocol as it is, and wants to learn additional information from the protocol. Right. So they don't actually use your data for in raw format, but they actually get intelligence from it. The third category is like untrusted CSP. So untrusted CSP is the service provider is not trusted. You don't have to trust him, right? So you say that okay, I store my data in the cloud, and I assume that the cloud service provider might use my data. For example, healthcare data. Healthcare data is like our biometric data, right? So once a person gets diabetes, he's it is like it is there in his health record, right? So in 2000, in the year 2000, he was actually diabetes. He was a patient who was diagnosed with high blood sugar. It doesn't change. Even in 2024, if someone asks, he will tell in 2000 I was actually having high blood sugar, right? So it doesn't change. It is like your biometric information. Anything like even you have a heart attack, or like the patient had some sort of illness like jaundice or whatever. It's like a biometric information. It is there. It has happened for him, and then it is there throughout his life. So basically, healthcare information is like very precious asset for all these medical industries. So what they try to do is like even if the data is stored in some untrusted CSP, they wanted to offer security for all their information. So when you talk about untrusted CSP, we don't talk about service level agreement or anything. So we only depend upon cryptography. So we go for privacy preserving techniques. We use encryption, we use access control, and then we also use integrity of data. Right, so all these things have to be offered. The data owner has to actually take care of all these cryptographic needs, and then store the data in the cloud where it is not secure. Right. So these are the three types of service providers, and the major requirement for cryptography comes under untrusted CSPs. So we have talked about the architecture. We have also talked about the cloud service provider, and where exactly cryptography is required. And the next one is like access control. So when you talk about access control, who accesses your data is main concern when it comes to medical records. So the right person has to get the right information at the right time. So that is why we need this access control mechanisms. And there are three different ways in which we provide access control: role-based access control mechanism, identity-based access control mechanism, and attribute-based access control mechanism. So these are the three types of mechanism which are identified for providing access control for medical records. So in role-based access control, what we do is like we restrict the system data infrastructure access to unauthorized people using pre-assigned role. So each person in the system will be given a pre-assigned role. For example, I am working in a hospital and I am a nurse, right? So what happens is like nurse gets some access to some of the information, and if I am a doctor in the same hospital, I get access to different information in the hospital system. Right. So basically, what we do is like we try to identify the roles for the system, right? If it is a hospital system, then you see doctors, patients, nurse, researchers, admin, etc. If it is like a library system, then you find out like people like students, librarian, the headmaster, the teachers, and so on. Different people get different types of access in the system. and so on, right? So basically, we actually consider role-based access control very powerful. So you can see here, like this is a pool of users on the left side, and in the middle you can see the roles, and we need to find out what rights can be assigned for each roles. So we don't actually assign rights to the person. Rather, what we do is like we create roles and then we actually try to provide access to the roles, right? So the first thing they do is like in role-based access control, for each role, what is the rights offered to the role? So it's a doctor, and doctor can view patient information, doctor can enter patient information, update information, etc. So he can, or he or she can do any of these things in a hospital system. And when you see here, like the role of a nurse is like very limited when compared to the doctors. So view patient information, sensitive clinical information can be seen, and nurse can access only these two. Nurse does not know how much bill amount is being levied on a person or a patient, right? So basically, it is like that. Like the patient will have their own access. They can actually view the patient information. They can send or share the patient information to someone, and bill information is also given to the patients. And researchers get only information to research information. They don't get access to all this information in a hospital system, right? So these are different roles, and they try to actually map to different rights, and then we assign the person. Each user will be assigned a role in the system. So this user is a doctor, so basically this user will be having all these rights. So this way we can actually increase or like reduce the roles, the rights to the roles, and then it with a very minor change, right? So a person is already marked as a doctor, and now if you just want to add research information to doctor, what happens is like you just need to change the roles and add this research information for this role, so that you don't have to go and work on users. So users may be in thousands, but the roles might be in like tens or less than 100, right? So there might be like 10 or 15 different roles in an organization. So managing roles is very easy when compared to users. So here in this system, we see like each user is assigned a role, and each role is assigned rights. So access control can be based on this. Now, how do you provide access control here, right? So it's very easy to draw a diagram like this, but then how do you provide access control for each of these roles is like a typical question, which is answered by the implementations, right? So one of the ways to implement this is like using Active Directory. Active Directories will actually find out the assets in the system and then provide which assets can be accessed by which roles, right? So typically we need to find a mapping, and this uh, becomes a map, or like it becomes a policy for the system, and this policy has to be adhered. So whenever a person logs in into a Windows system in an office or a college, if the student, if it is a student login, then what happens is like he or she gets only a very limited access to the network. uh, they cannot actually access the web page information stored by the college or something like that. They will be limited to only the library access and only for lab practicals and so on, right? So the same way, this has to be made as a policy, and this policy will be present in the policy server. And each time you log in, you will be provided access to only those systems which you can access. So this is actually done by Active Directories in Windows, and LDAP is like lightweight directory access protocol. LDAP is actually widely used in the industry for access providing. The second type of access control is like straightforward, like we don't have any of these controls, like it is just using the identity of a person, right? So identity may be anything. Identity may be the telephone number, email address, or social security number, or an employee number in an organization. Anything can be an identity, and based on the identity, you actually create the private key. So there will be a escrow or a trusted entity which is providing the secret keys for this is the people in the system. So they have to register with their commonly known mobile number and email address, and then get the corresponding secret key. And using the secret key, they can access anything in the system. So there is no you don't have any assets or anything mapped to it, but it is just like using the keys, secret keys for accessing the system. So this is actually provided by identity-based encryption systems. So this is actually a separate category of encryption schemes where the identity will be the public key of a user, and the private keys of the user will be derived by a private key generator who is a trusted third party. Going to the third system, this is very interesting and a very useful system these days, attribute-based access control in electronic health systems. So what happens here is like access to the system data infrastructure is granted if user has a desired attribute, right? So this is actually one of the main applications of modern cryptography, and it is actually achieved using attribute-based encryption systems. So attribute-based encryption systems were introduced in the year 2005, and then after that it has got a lot of traction, and there is a lot of research happening on attribute-based encryption. And there are two types of attribute-based encryption. One is like ciphertext policy attribute-based encryption, and the second one is like key policy attribute-based encryption. So we'll just see in brief how these two things work. So in attribute-based encryption systems, or access control systems, what we have is like each user in the system will have a specific attribute. This is like the roles which we talked in the role-based access control system. But here you can see like attribute for a doctor is like what is the specialization of the doctor, and the affiliated hospital name, experience, and gender of the doctor. So we can have any number of attributes like this. You can have whether you can also add like whether he's available at nights, whether he is available all for 24 hours, and all these things will be considered as attributes, right? And for patients, the attribute will be the location, what ailment they have. It may be based on their age, gender, weight, and any of the attributes which describe a patient, right? And for nurse, you have like what kind of nursing type they belong to, and which hospital they are affiliated to, and experience and gender. These are general examples of like attributes. We can go to some specific things. So here for a doctor, the attribute we have described as specialization, affiliated hospital name, experience, and gender. So these might be like specific examples, right? For specialization, you can see cardiologist. The doctor might be a cardiologist, might be a neonatologist, oncologist, etc., right? And he or she might be affiliated to any of these hospitals, and the experience might be like junior, number of years of experience you can add, or like it might be a senior level or any of this, right? And gender might be male or female, and so on. And patients will have their own attributes the same way, and the nurses will also have their own attributes like nursing type, whether the nurse works in the ICU or home care or operation theater, or a staff, or a labor in labor ward, or etc., right? So these type of classifications you can provide for different roles. Now, when you consider attribute-based encryption, there are two types, I said, right? So one is ciphertext policy, and the other one is like key policy attribute-based encryption. So these are used for providing attribute-based access control mechanisms. So basically, this is an encryption system which uses the attributes for encrypting the data, and the person who has the corresponding secret keys to the attribute will only be able to decrypt. So that is how you provide cryptographic security for your assets, digital or medical assets, right? That's how this whole attribute-based systems work. This is the principle of it. I'll just show it in an example so it will be clear for you. So let us consider this is the medical data which is present, and this has to be encrypted to a person, a doctor who is a cardiologist, and the doctor might work in Apollo or Mayo Clinic, and the doctor might be a senior level, right? The doctor should be in a senior level. So the experience is set to be senior level and the gender should be male. We want to encrypt this data, the medical data, so that any doctor who has this set of attributes and the logical combination of them, right? We need to also look into the logical combination of this. You can have any logical combinations here and or can be used based on our requirement. So a patient wants to share this information, or like any organization wants to share this information based on this attribute, they can generate the ciphertext. So this data which is encrypted for an access structure. That means a doctor who has a specialization in cardiology and affiliated to one of these hospitals, and a senior doctor and should be a male doctor, can actually decrypt this data. Now, when this data goes to this doctor, the doctor who has the private key actually has uh, uh, the combination to actually decrypt this. So here, if you see, the private key will be having a set of attributes, which is like specialization of the doctor, which is cardiologist. He is affiliated to Apollo Hospital, and the experience level is senior, and the gender is male. And now what happens is like with this private key, he will be able to decrypt the ciphertext and get this information uh, back, right? So basically, what we do is like we enforce the policy on the ciphertext. So that is why it is called a ciphertext policy attribute-based encryption. So this is actually the policy. The encryptor will actually decide the policy who can decrypt the data. That is where we enforce the policy. That is how this data is being encrypted and sent. And the person who has these attributes will be able to open this data. Hope this is straightforward. And let us see this example. This was encrypted for a cardiologist and then affiliated to one of these hospitals, and the experience is senior level, and the gender is male. Now, if you see, this ciphertext cannot be decrypted by a doctor who is a psychiatrist, and all other attributes match, right? Apollo, senior, male, all these things match, but the specialization do not match. So with the private key of this doctor, it is impossible to open this data or decrypt this data and get the data back. So this is how attribute-based ciphertext policy attribute-based encryption systems work. And this has a very interesting property. Like when I said about Active Directories and LDAP, all this data is like plain, right? None of the data is encrypted or like the access is only through policies. People, the LDAP has a policy which says that this role has access to these data, but the data is not encrypted to that role. It is only like a logical partition between the data and the access. But here, even if someone has like infinite computation power, right, they will not be able to decrypt and then get unless they have the right attributes to decrypt the data. So that is how this cryptographic scheme, the attribute-based systems provide ultimate security for your medical data. So this is just an exercise. So whether this attribute will be able to open this ciphertext, right? So it will not, because the gender is like female, so it is not going to open. So key policy attribute-based encryption is the opposite of this. You could see here, attribute-based encryption, we actually have encrypted for these attributes. So when you encrypt this data, what you are going to do is like the encryptor has to choose the attributes. These are the attributes which are being required for the decryptor. So the decryptor should actually have all these attributes for decrypting this data, right? So cardiologist, Apollo, senior, male. Only this doctor can actually, only a cardiologist who works in Apollo and in the senior level and a male can actually decrypt this data. So the ciphertext does not carry the policy. So the policy is in the private key. So if you see the private key, a doctor might actually work for 2, 3 different organizations, or nurse might actually go for, or like doctor may go for consultation in 2 different hospitals and so on. So in this case, what they do is like they don't actually have to specify the policies on the ciphertext. Rather, they do it on the private key. So the doctor who is a cardiologist and works for any of these 2 hospitals, and he is a senior level hospital doctor, and he's a male, can actually decrypt this data, right? So the policy is actually enforced by the private key. Now, if you see like here, the data is being encrypted for a psychiatrist, but again, the same way, right? The policy is actually saying that this doctor is a cardiologist and he is not entitled to open the data being encrypted. So typically what we do is like who can decrypt the data is enforced by the encryptor, and the people who are having the keys, they should have the corresponding attributes in some logical form which actually matches these attributes to decrypt it. That is how this works, right? So this is a very interesting cryptographic scheme, attribute based encryption, which finds application in attribute based access control mechanisms. So this is actually a recent trend in access control field, in the field of access control. The next thing which we are going to see is like emergency cases. So we know that there might be emergency cases in which we need to actually access or the doctor needs to access the health record in order to provide a good medical support for the patient, right? So here you can see like for emergency access control, the requirements are like this. The patient might be in coma and not physically or mentally capable of accessing the data, right? EHR might be private to him, but if the patient is not responding, then there is no use in the data. So there should be like there might be failures in smart cards, or biometric failure can happen, so that the electronic health records cannot be used. And sometimes people also forget their usernames and passwords, and they cannot actually use the EHS system. And privacy and security for EHI system during emergency situations is important, like COVID, right? During COVID, we cannot actually go to the hospital and then show our reports to the doctor and then do like it has to be given in an emergency situation. So access only to the necessary data. So again, we need to provide only access to the necessary data, and not all information has to be sent to the doctor. So on. So these are like the key requirements for emergency access control. So if you see here, like in emergency situation, we may actually provide the access, but then we need to also revoke the granted permission to the data, right? So these are the key requirements for emergency access control. So there are 4 different ways in which we do this, like private key storage. What happens is like a central authority will be escrowing the keys, like for each of the well, again we need to actually enter into service level agreements and then say that if my medical record is lost, then this escrow or this central authority is responsible for it, and so on. And for smart cards also, we have like we can use additional information for accessing the smart cards, like getting an OTP in your mobile phone, or like multi-factor authentication, and these type of techniques can be used. And there might be an emergency responder who actually works or like who takes care of your health records. So this is like a physical mean, right? So you may have a bystander with you who will be actually providing the healthcare information. And the 4th way is like break glass, where a doctor in an emergency situation straight away accesses the data with a elevated privilege, right? So we need to have privilege escalation here. So the doctor actually tries to access your data with more privilege, and we need to have mechanisms for providing escalated privilege for the doctor. And here again, we need a lot of other mechanisms where we need to audit the patient's data, how much of data has been transferred to the doctor's account, and we need to actually take make sure that the original data is not being changed. So these are the mechanisms. Like for that, we need to use HMACs or digital signatures so that we can verify whether the data is being altered after use or not. The next thing which we need to see is like sharing of medical information. So here we come across like the data has to be shared, as we know, like we need to share the data to various entities. Like we need to provide the data to doctors, we need to provide the data to bystanders and so on. Like electronic health records has to be transferred to people in an efficient, or like shared to people in an effective way and in a secure way, right? So here you can see like there are total data sharing, selective data sharing, and social sharing. So these are the three techniques in which we can actually share the data. So here you see like a patient wants to encrypt the data using a root secret key. So there is only one key which the patient uses to encrypt all the data, like all electronic health data. The dental data is encrypted using this key. Optometric record is encrypted using this key, and so on. All the medical records of this patient is encrypted using this same key. And what happens is like if at all the patient wants to share the information to a dentist, uh, he or she has to share the root secret key to the dentist. The key is given to the dentist. Now the dentist can access the dental records. He can decrypt and then see what are the treatments given before, and then what medication she or he is in, the patient is in, and so on. The risk of this is like the key can be used to decrypt any other record. So if the doctor gets access, if the dentist gets access to other medical records, they can be easily decrypted, and this medical record can be used for any other purposes. So basically what we do is like selective key data sharing. So using the root secret key, what we do is like we derive multiple keys, sub keys, and these keys will be used to encrypt different records. So in order to do this, what we do is like we have all these mechanisms like HMAC, KDF, PRNG, and PBKDF. So these are like cryptographic primitives. HMAC is like a keyed hash message authentication code. Key derivation functions, which are, so this is actually HMAC is like a hash function with a key, right? You can use SHA-256 or like any of the standard hash functions, and the MAC is designed in such a way that it actually takes not only the data but also the key, one key as an input, a symmetric key as an input, so that the tag can only be generated or like verified with the help of that secret information and the data. So it is like a digital signature of one. It's like a digital signature on the data, which can be generated and verified by the same person who has the secret key, right? Symmetric key is like a secret for a single person. It cannot be shared between two people. So that key can be used, or like if you want to verify, if the third party wants to verify, you need to actually reveal the secret key. Only then the third party can verify the HMAC. The same way we have like key derivation functions for ephemeral keys. So Diffie-Hellman or like RSA keys can be used for generating a ephemeral key, which ephemeral key can be used along with the key derivation function to generate multiple keys, right? So these are like cryptographic techniques in which we can use keys or derive keys from a single key. Pseudo random number generator is one another way where the seed will be a secret, and that seed can be used, that will be the root secret key of a person, and that can be used to derive multiple keys with multiple information in the as a seed. PBKDF is another mechanism where password-based key derivation function takes a password as input, and it actually generates a long key for use, right? So along with the password, different passwords. If you input different passwords, you will get different outputs, which can be used as keys for various purposes. So these are like the standard techniques, cryptographic techniques, which are used for deriving keys. And for searching, what we do is like, so basically all this data we are talking about is like encrypted and stored. It is in the cloud or it is in the database, whatever. We say that it is encrypted. So once the data is encrypted, it is very hard to identify or to search on encrypted data, right? So AES, if you are using AES encryption, you can if you have worked on encryption schemes, you will know before encryption you will see like some pattern in the plain text, and after encryption you will see no pattern in the ciphertext, right? Ciphertext will be random, a spray of zeros and ones. So what happens is like you don't see any pattern there, so you cannot actually do an effective or efficient search, or you cannot even search for keywords in the system. So basically there are mechanisms which are generated, like searchable symmetric key encryption is one of the techniques which is used for searching on encrypted data, right? So I'll just explain in brief what is this naive search. So when a medical data is being encrypted and stored in the cloud, it is encrypted and stored, it is uploaded to the cloud. Now if you are using a naive search, you cannot go and run a search on this encrypted data, right? And this is also in the cloud, so the cloud service provider will know what you are searching for and what keywords you are searching and so on. So these are like security requirements for searchable symmetric key encryption schemes. Now in order to solve this, what we need to do is when you want to do a naive search, you need to download the whole record or like a piece of record, and then you need to use the key which is locally stored in your machine, and then search on that decrypted data, right? So this is actually a time-consuming process, and then you don't really want to download all encrypted files and then search on encrypted files. So that is why we come up. So the researchers have come up with searchable symmetric key encryption systems, where you see like the security. There are like various security requirements for this searching in symmetric encryption, right? So the first requirement is this. The security requirement for searching is the server should not be able to distinguish between documents and determine searched contents. So we have encrypted and stored, so our search should not reveal or it should not be able to distinguish between two documents. The service provider, the cloud service provider, should not be able to distinguish between documents, right? The second one is like keyword privacy. The cloud service provider should not know for what keyword you are being running this search. So for example, in a hospital, there might be a lot of cancer patients whose records might be like very, very secure, and they don't want to actually reveal their illness to the public, right? And this cloud service provider is very much interested in knowing how many patients of this location is being affected using this specific type of a cancer or a disease, right? So this type of information they are really looking at. And even a curious cloud service provider, honest but curious cloud service provider, they may be interested in this type of information. But this will also be a sensitive information, right? So if someone knows that, okay, in Chennai area, there is some specific disease which is very, very prevalent, then people will start doing focused advertisement, and then they will be starting focusing on the people who are actually having the illness for selling their drugs and so on. So these type of issues might happen. So what we need to do is we also need to provide privacy for the keywords which are being used for the search. So the cloud service provider does not know what keyword is being searched, and secrecy for the query. So any query which is generated, the server should not be able to generate any query. It should be only be able to generate by a secret key, right? The person who is querying will be having a secret information which the cloud service provider will not be having, so that the query can be run only by this specific person who is allowed to run on the run the search, right? So that cloud service provider himself will not be able to run unless he knows the secret information. So the cloud service provider should not also be able to understand what is the outcome of this search, all right? So now let us say there are 10 records, and out of this 10 records, the search landed up in 2 records. Now the cloud service provider should not know that, okay, this search relates to 2 records. And next time when a search comes, he should not be able to map these two records and so on. So these are the type of stringent requirements people who are working on EHR security has made for searchable symmetry key encryptions. And access patterns, right? So which which documents are being accessed frequently, this should not also be known. So there will be some pattern which is being revealed out, and then the cloud service provider might get some information about access patterns also. And the query patterns also, they should not be able to link two different tokens which are being queried as the same, right? So query pattern should not be also revealed. So these are the security requirements, or these are like very, very interesting security requirements for searchable symmetric key encryption schemes. And people have actually designed schemes to provide or offer all these properties in searchable symmetric key encryption systems. So one such technique, I just wanted to expose you to this bitmap index technique, where what happens is like medical records are actually initially, before uploading the medical records to the cloud service provider, what we need to do is like it is being the keywords are extracted, right? So from the medical records, the keywords are being extracted, and against the keywords, the records are being mapped. So this is actually called as a bitmap, which has a map between the keyword and the record index. So R1, R2, Rn are all record IDs, which does not, these are like masked record IDs, right? And these keywords, they are not the full keywords, they are actually masked keywords. And based on this masked keywords, you know to which record, masked record, the keyword is assigned. So if there is a 1, then it means that keyword 1 is present in record 1. If there is a 0, keyword 1 is not present in record 2, and so on. This is just a plain bitmap index. And now the encrypted record is actually stored in the cloud service cloud, and it is encrypted and it is uploaded to the cloud. And only the bitmap is present with the user. And this bitmap can also be sent to the cloud service provider, right? The cloud service provider does not know what is K1, what is R1. He actually knows only there is a bitmap and there is a bunch of encrypted records, and he has to perform the search on it. Now, if the user wants to search for a keyword K1, use the keyword with the SSE, and this is the searchable symmetry key encryption's input. We give the keyword as input, and it actually converts it into a tag. K1 is a tag, it is not the keyword itself. And now K1 is sent for the search. And now it retrieves the values, which records correspond to K1. So R1 to Rn are the records which are being mapped in the bitmap, and these records are being retrieved and then sent to the requester. So now the problem is, right, so there is a huge problem which was solved recently. What you see here is like the bitmap is actually uploaded to the cloud, and now let us say the person is requesting for a keyword K1, and it is present in multiple files, R1, Rn. Like here you see like 2 files are there, and now let us say the cloud service provider responds with only one, R1, right? He does not send Rn. He says like, okay, the keyword is present only in R1. How do you identify that, right? So now there is a mechanism which actually uses HMAC to address this issue, right? At the end of this, they will be actually generating a HMAC, all these bitmaps which is being generated. So this keyword, if it is present in R1 and R2, R3, then what you have is like 111 and all zeros, and this bit representation will be used in a HMAC along with the secret key, and it will be uploaded to the cloud. Now the problem is simple, right? It can be solved. Like no one can actually, the cloud service provider cannot dupe, because he has to actually send the records as well as the HMAC, which can be verified at the receiver end. The receiver has to verify the records. He has to decrypt the record and then check whether the HMAC is like valid. So this is an advancement in this field, and this is how we do searching. So until now, we have seen like various cybersecurity or privacy-related issues in electronic medical record systems, and I just wanted to also expose you guys to the design principles which we have used in medical devices. So which actually helps in providing cybersecurity to embedded systems and IoT systems which are used in medical field. Right. So typically, the organization which I works on, or like we actually manufacture medical infusion pumps, and these medical infusion pumps are used for infusing drugs to the patients, right? So you would have seen drips in hospital, which is used for infusing saline water or like medication to the patients. So these infusion pumps are like embedded devices which actually run on Linux or Android operating systems, and they actually are used for infusing drugs in a precise uh, rate, or like it can actually precise quantity to the patient, so that the drug delivery will be like very precise. That is the idea here, and these applications have to be verified whether they are secure to run on a remote environment like a hospital, right? So I will quickly go through these slides, and then we'll see like. So these are the main design principles which I wanted to expose you guys to. So security by defense in depth is one of the key techniques which we use. Principle of privilege, separation of duties, security throughout the life cycle, and simple to use systems, and use Kirchhoff's principle. So these are the main design principles which we use in medical devices. So security by defense in depth can be easily understood by this diagram. So there is a castle, and in order to actually safeguard this castle, what we do is like the people initially they built walls, and these walls are not very safe. So people can drill hole on the wall, and then they can easily enter into the castle. Right. So the next thing they did was like they actually made a uh, pond around the castle, and then they filled with water, and then they understood that people can easily swim in the nights without being observed, and then they can actually try to drill a hole on the castle and then enter the castle, right? So the third thing they did was like they actually put in alligators into the pond, so that alligators will not allow people to swim, and then that's how they were actually trying to uh, build a defense by increasing the depth of access, right? So this is actually a classic design technique for security. So if you see here, any web application, so let us consider any client server application works in this way. The user has to actually log in into a client machine, and this client machine will be actually giving access to a server, and the server will be accessing a database which is in the far end, right? It is in the rear end of the whole system. Now, this is actually a very generic system in which we have to actually offer a defense by providing various security mechanisms right from the beginning. So the user has to access this client machine using techniques like passwords and multi-factor authentication, and only if we provide the proper response to these questions, he will be provided access. This is the first entry point, or like this is the first point in which he will be checked. And the second thing is like the client to the server, there will be a TLS communication, so that any unauthorized access cannot happen to the server. So server responds only to a client machine which has the proper certificates, or like it actually has a firewall which can actually check whether the client machine will be actually providing is actually a whitelisted one to access the server, right? And the same way, we also have WPA security for wireless. If the client is accessing the server through a wireless communication, then we have wireless security protocols which can actually help us to secure the communication. The same way, the server connects to the database using a TLS communication, which is a trusted communication, and it will be talking only to a server which is legitimate, and it has the credentials to access the database. So now you can see like the user has no way to access this database by bypassing all these things, right? So if at all he or she wants to do this, access the data in the database, you can consider one example as like SQL injection. I don't know like how many of you know or like can recollect what SQL injection is. So basically what happens is like wherever you are processing the input, right? So this username and password is entered in a field, it is entered in a form field, right? So now it is not restricted that you have to only if it is not restricted that you have to only enter like 10 characters for username and like 15 characters for password, and you can actually enter any number of characters. Now what the person can do is like, we know that this data, the username and password, is going to be searched inside a database, right? Select username from database user, and the password is so and so. Now, there is a way in which they can actually tweak this SQL query in the background by manipulating the input. You don't actually have to type in the username and password. There will be some mechanism in which they can actually make this SQL query logically true so that you actually get the response from the server, right? That is SQL injection. Now, defense in depth mechanism is one of the ways in which you can actually restrict access to the database, but there might be some vulnerabilities which are there in the system which can lead to actually which can lead to a break in the systems, right? Uh, just a minute. Uh, Yeah, so I think we are running out of time. I had few more slides to be delivered, since there are like other there is other resource person who is waiting. So I'll just quickly skim through the slides and then I'll just close the session, right? So the second principle which we use is like principle of least privilege. So don't give anything by default, right? We need to actually provide access only when it is required. We have to restrict all these accesses like SSH, FTP are like very dangerous permissions for a system. So we need to actually restrict all these accesses. And security has to be thought throughout the life cycle of the system, and it should not be actually considered only during the development or only during the design phase or anything. So it has to be considered throughout the system, and then it has to be security has to be considered when it is being installed, when it is being tested, when it is being in the production, and even when the requirements are gathered. When we are designing a medical system, we need to actually understand what are the requirements and what are the security requirements for the system. So separation of duties is also another thing which we can see, like, and the power should not be given to a single person. So even in the bank, when people want to access the bank locker, you will not be given only one key, right? The banker will have a key and you'll be having a key, so that you both have to work together to actually access the data. So threshold encryption schemes and schemes similar to these are like used for separation of duties. And design principle, one of the key design principle is like simple to use. So this is actually, you need to actually have easier ways to for the right guys, right? For the bad guys, it should be like a very long way to break into the system. So we cannot keep on increasing the size of the passwords to make the system secure, right? It cannot go indefinitely bigger. The passwords, even like if you go beyond like 10 characters, I think it is very difficult for us to remember on a long run. And for multiple web applications and applications, we need to remember multiple passwords, which becomes an overhead these days. And whenever we are designing crypto systems, we need to use Kirchhoff's principle, which is like keep the key secure, not the algorithm. So algorithm is public, RSA algorithm is public, AES algorithm is public. All these algorithms are public. Only the key has to be secured, right? So the future trends are like we see a lot of generative AI solutions being used for security. As I told you, 81% of the attacks are like based on AI bots and AI induced, right? So AI is playing a main or major role in cybersecurity these days. Privacy preserving machine learning is another technique or another area of interest for medical devices and any other field, right? So even for finance, even for any other field, it is like very important. Privacy preserving techniques are being used, and post quantum cryptography is another research area which is having a which is a promising area for medical devices. Like we see like a lot of IoT devices, medical devices, and embedded systems which are like resource constrained, and now we are actually testing whether these devices can run post quantum algorithms on them, right? So this is just a summary, and thanks for your patience. And if you have any queries and if you want to discuss more on any of these fields, you may please contact me in these email IDs. These are my email IDs. One is my official ID, and the other one is my personal email ID. So thank you so much for your time, guys. So Praveen, is there a question answer session or something like that? Hello. Hello, Praveen. Can you hear me?
Yes, MSc. Am I audible?
Yes, I hear a lot of echo.
Vivek, thank you for your wonderful session, Vivek. It is indeed a great pleasure to have you as a resource person for the inaugural and followed by the first session. You have detailedly explained us about the complete view of medical IoT system and the security requirements and the cryptographic primitives and basics which are all required and the models and techniques and whatnot. You have extensively covered everything. Hope all the participants got the most benefited informations. So we thank once again for your valuable time, Vivek. In future, we can again connect and hope all the participants can reach Vivek again. Uh, Dr. Vivek is cybersecurity specialist. He has completed his PhD from IIT Madras. So for any kind of collaboration, you can hope Vivek is open to collect and collaborate. You guys can use this opportunity. Thank you, Vivek. Thanks for
Thank
your
you so
valuable
much.
time.
Thanks so much for your invitation. And then I hope it was a delight for people who are interested in starting their career in like security or like cryptography. And if anyone is like willing to discuss more, please feel free to contact me. My contact details are there in the slides, as well as you can reach to Praveen and get my contact. Thank you so much.
Uh, Thank you, Vivek.
Hello, sir.
Good evening, Professor. Am I audible?
Good evening, sir. Good evening. I'm audible, sir.
Yes, yes, Professor, you are audible. Just a second, Professor. So, I would like to welcome Professor Mohammad Farooq from NIT Warangal, Assistant Professor, Department of Electronics and Communication Engineering. He is joining with us for the day one, session 2 on medical IoT device architecture and communication protocol in healthcare system. Our resource person has extensively working on biomedical image processing, SAR imaging, deep learning for healthcare and computer vision. SAR has worked on several research projects, namely few empowering health AI enhanced remote monitoring for early patients with wearable biosensors and AI driven telemetry data analysis for enhancing performance in radar and satellite communications. AI powered computer vision for smart agriculture and healthcare application, computer vision and image processing oriented. Uh, SAR has extensively has the knowledge on medical IoT devices architectures. So we would like to welcome him for this session. Hope hope you can share your screen and start the session.
Thank you, sir. Thank you very much for your invitation and for kind words for my brief. So I'll share the screen now. So my screen is visible, sir. Hello.
Yes, Professor, your screen is visible.
Okay. Yeah, yeah. Oh, good evening, everyone. So related to this program, uh, my title of the talk would be medical IoT device architecture and how we can utilize various communication protocols related to medical Internet of Things devices. So related to this talk, my agenda would be related to how we'll start from introductions and we'll see Internet of Things in healthcare and various device architectures are there, and we'll discuss about various communication protocols, and also we'll see various security and privacy concerns, and as well as we are going to discuss certain applications and challenges, and we are going to discuss certain trends, what are the future trends are there. So related to with respect to Internet of Medical Things, there are many kind of applications which are really available nowadays. That means if we discuss future trends, so moreover like IoT is became very popular in current trends. So related to concern of network of connected medical devices, software applications, and whatever the health IT systems are there. That means basically in terms of Internet of Things, first we'll talk about what is Internet of Things. That means in Internet of Things, basically there are many devices which are equipped with the internet, and it would be a considered as a object, and every objects are able to connect to each other, and we are able to sense the informations in terms of various sensors. So basically IoT is the major part of the current technology, because which we are using like mobile phone or various wearable watches and many devices which are readily available nowadays, or like home appliances, so many things which we are using. So that means the devices equipped with the internet, and that is considered as a network. So network of interconnected devices, and that devices are responsible, and it can collect the data and exchange the data, and we can see that act on data through the internet. That means through the devices, all devices are able to communicate each other. And these devices basically, which we have seen that earlier days, we sensors, embedded miniaturizations. Uh, as well as we have seen that miniaturization of devices, as well as we have observed that once we have seen that revolution of artificial intelligence has been started. So that means we have included AI concept, and then we are going to see that the data which is collected devices, and the devices are able to uh, uh, with respect to adaptation. That means we can say the devices became smart devices. So system, that means sensors became smart sensors, actuators, and system has considered variable appliances. So various devices which consist of variable sensors, as well as once we will talk about healthcare domain. In terms of healthcare domain, the data which is collected through various medical sensors, medical equipments which are available in exchange the health data, and we want this data, it should be work in a real time, and that means go for the low latency task. So implementations which are readily available for patients care and outcome, that means we can get the data from the patients, and it should transfer the data patient to the like particular hospitals or particular doctors or medical practitioners. They can get the information. So that would be very important nowadays, because in the daily life, in busy life, the people are not able to manage their health concerns. So interconnected system which are includes various sensors or smart implants or equipment which became digitally very strong, and all working to enable continuous patient monitoring. That means we want to go for real-time health monitoring system or early detections of various chronic disease. That means we can measure the various health issues related to diabetic conditions, related to cardiac conditions, or more personal. So according to that, some current trends which we are seeing, like predictions of the what will be the complete future of the IoT would be there. That means, as I said, AI and machine learning, that integration already has been started from the past 5 to 7 years, and the future of IoT is will heavily leverage the particular AI and machine learning and deep learning to enhance the predictive analytics. That means we are going to predict particular kind of disease, as well as we can provide the personalized patient cares and automated disease making process. That means whatever the disease decision making process we are looking, so we want to provide the automated decision making process with respect to various chronic diseases. So we know that IoT, the concept is not a currently new. It's a very well advanced it reached to very well advanced level, because we describe the various sensors. Initially, we have understood that sensors are connected to microcontroller, microprocessor. So we have seen that microcontroller at has reached to advanced level, as well as we equip with the internet. So network of physical objects, and that is considered as a things, and they are embedded with sensors, and also it should require certain softwares and many technology. That means many communication technology. We started from Zigbee, then we have seen that Bluetooth, then Wi-Fi, then WiMAX. So that means they want to connect and exchange the data with other devices and system over the internet. So that means in the medical things, it is very important, because we have seen that we are looking for personal healthcare and as well as medicine domain. So medical Internet of Things, also called Internet of Medical Things, an application, the various IoT sensors or IoT technologies which are applicable to healthcare system or which are applicable to medicine. Let's see the example when we want to empower AI specifically to the elderly patients, or we want to develop a system for elderly patients. So we want to connect the patients with various variable sensors which are able to monitor the elderly people which are unable to move and which are difficult to travel. So under that conditions, all medical sensors and healthcare devices which are uh, readily available, and we can collect, we can provide particular monitoring of the patients, and we can see that data would be collected through various communication system. So that means communication technology will be very important here, as we are in the field, the era of 5G. We are looking for 6G development. So that means more data can be transferred, more data can be collected, and also we are looking that whatever the processing time we want to reduce, how we can reduce the processing time. That means we are moving from cloud computing to edge computing. So various edge devices has been developed. That means the data which is collected from the source and it will be processed at the cloud will be the time taking process, and we cannot reach to real time manner. That means we are unable to reduce the latency. That means latency part need to be reduced. That would be done at the edge level. So edge computing, as we can collect the data and at the source and near to source. That means edge devices are responsible to process them and send them to the particular doctor or particular hospitals, and then we are getting healthcare professional. That means they are going to utilize various equipments or various gadgets, digital gadgets like tablet, laptops, many things. By that way, then we are cutting down the paperwork or like data which is extracted from the various sensors sent to the particular professionals, healthcare professional. They are able, which can be applied at the home also, infusion pumps, imaging systems that can be available at the hospital level. But that is the digitally very strongly they can collect the data and which can be connected to the network, and also the real-time data flow, which are very important, like various vital parameter which will be extracted from the patient in terms of ECG, in terms of or BP or oxygen level, glucose level, temperature, many other parameters that can be continuously extracted and collected from the patient through the sensors, variable watch, variable devices, or variable bands are there which are required and sent to the doctor's hospitals. That means it will be just create a network and patient doctor connectivity which will be done at the remote level only. So remote monitoring, and there is a telemedicine concept will include here. So that platform will be converted into telemedicine, and that platform will allow the doctors, will allow the medical professional practitioners to inform the decision without the patient must be visited physically at the hospital or at the clinic. And later the data which we are collecting continuously, that is very important because that will give the analytics. And it will give the major supports, that means to improve the decision making capability. That means here AI will involve. So collected data can be analyzed in real-time manner. At the edge, computing will involve to process the data at the edge level and detect the anomalies and detect the particular chronic condition of the patient and trigger the particular alert, send the alert to the particular devices which are available in terms of mobile phone or tablet, or it will be informed to the hospital as well as particular parents which are taking care people are there, their guardians are there. So these all kind of things which will be transformed in terms of medical internet of things. So what is the importance part in IoT in healthcare? That means when we are talking about Internet of Things towards the healthcare domain, we can observe that the remote monitoring of the patient is very important part. That means when we are talking about many data that will be collected from various sensors as well as various diagnostic equipments which are required to monitor the health of the patient. So we want to monitor the health of the patient, and also we can say the condition of the patient in what condition. And if we track them in early stages, some diseases are able to rescue very easily when we are able to identify in early stages. So IoT devices continuously will monitor the data remotely. So remote monitoring of the patient is one of the important part in healthcare domain, and we have seen today's trends and in various countries like Japan, China, or like European country or US, they are correctly using such kind of gadgets like very easily, like ECG patches are there, smart watches are there, glucose monitors are coming in different manner. So they are able to continuously collect the patient's vital data, and we can measure the various vital sign of the patient. And also doctor can continuously access this data in real time manner when the patient is available at home, and that can be easily examined by the doctor through his port, through his uh, particular process would be there. So we can see we can reduce the risk of the various chronic disease or certain condition that is very harmful for the patient, like sudden cardiac condition will deteriorate the health of the patient, and diabetic conditions, hypertensions, all these are the heavy high blood pressure, all this kind of condition can be reduced. So by that way we can reduce the risk of the patient, and particularly it will be helpful for elderly care, because that is very important aspects for our society. They are unable to move, and we are unable to care with respect to, so they are staying in particular in the remote areas. So patients that can be easily handled here in this domain. And early detection of disease, that means data which is extracted, we are going to provide the particular data collections, and after the detection of abnormal trends, that means various irregular heartbeat will come, or oxygen level will drop, or particularly the person is suffering from diabetic, that glucose level has increased, all this kind of abnormality can be detected. For that we are going to deploy various advanced machine learning algorithms. Like in today's trend, we have implemented various AI ML tools that will be integrated to IoT, and we can predict the health situations. We can provide the when they are under the abnormal conditions, when they become critical conditions. So we can inform them, we can alert to the medical professionals, hospitals. So it will helpful for preventive healthcare. That is the major important parts of IoT in healthcare rather than reactive treatment. So this all kind of concept which has been added in a current technology. So we can say that reduce the hospital visit, reduce the paperwork, reduce the timing of the registration or discharge summary report, many things by the electronic health record data which has been extracted directly through the our digital devices. So routine checkups also we can easily handle, because we can say that remotely doctors are observing and getting the data through IoT enabled telemedicine. and patient need not required to travel frequently. Patient can save, we can save the time, we can save money, and also particularly the hospitals which are focusing on resources. That means they can provide the situation for the critical patient rather than overcrowding. That means the crowd in the hospital also will reduce rather than whatever the critical patients are there, we can manage to them. So that is the major benefit of hospital visits. Also, we have the one more advantage towards the direction of efficacy and lower cost, because IoT devices basically are automated data collection. As we know that once we are wearing the watch, we can see that every hour we are getting the details. What is the particular body behaviors or symptoms are there in our body, which can be easily analyzed. And also we don't want to collect the data through various paper and like that. So like that in hospitals, if the people are visiting, they are just registering through the mobile number and they are connecting to the doctor. Doctor will just observe and they can give the prescription through the same e-prescription, and then it will be it's just transferred through the WhatsApp or many other software. Efficacy and lower cost. And hospitals, they are able to optimize the whole staff. They can track the various devices which are available in the hospitals, like various wheelchairs are there or various other equipments are there that can be easily identified. Also, we can optimize the staff allocation by using of smart devices. That also smart, by the smart trackers are available that can be tracked very easily. So that is the major important part at the hospital level. And also preventive care basically lower down the long-term treatment. Sometimes the people patients are taking long-term treatment, so it will reduce. And also that is major part in insurance companies, they want to connect immediately once the any emergency will be happen in the hospitals, and patients should not suffer. So directly the insurance companies can connect to the hospitals, that will just accurate data will be claimed, and easily the process will take less time and immediate. Once the hospital just provide the electronic health record data, as well as it will provide the discharge summary immediately. That means it will not take much time. All this kind of thing will reduce the cost. It also reduce the fish. It will also reduce the burden. Many things. It will improve the efficacy of this. So what are the current trends in the market? If you're looking the market, as we have seen that when we observe that when we started processor, and we have seen that at high end, high implemented. Now we are looking with provided towards the, because we are looking at society, how we can reduce the, and how we can, like the life expectancies are increasing in terms of women devices which are exponentially. And we know that devices which are available with respect to variable point of view, that fitness bands are there, ECG patches are there, or various patches related to glucose monitoring and all, and various hospital equipment. Means like that which we were seeing earlier days, now it became smart beds connect with various sensors, various ventilators are there which are connected to various infusion pumps are there. So because of the rapid growth in IoT enabled devices, it became very strong because of all this digital technology has involved in this. in this implementation. As well as now I already told, communication would be very important here because we are looking 5G and we are looking 6G domain. All these kind of applications which are very important, and we are looking advanced at the smart level. That means AI acceleration will be very important and will provide the accelerating adoption. So 5G, 6G that are going to provide the high bandwidth as well as low latency. So high bandwidth, low latency is very crucial and very important toward of real-time monitoring. That means real-time health monitoring system, telemedicine, telesurgery, or emergency care. So emergency medical services are very important. Cardiac arrest or certain conditions which we want to rescue. Like important if you are going to monitor the patient in real time. As well as the same domain, we have seen that to shift to the edge computing, and AI also will be integrated here. AI in terms of machine learning, deep learning, which are responsible to reduce the dependency on cloud. We don't want to depend on cloud. It will take time. It will also more at low latency and high. So at the decision level, we have reduced the distance between source to the computing devices. As well as healthcare, the market of healthcare has grown in the current technology. That means if you will see that the particular difference in the technology, like we are looking the 2010, the technology was implemented at that level 6.8. Now we have seen that total 50 billion smart object has been developed. That means that is the rapid adoptions of the digital infrastructure which we have seen in the various field, and 5 times faster than electricity or telephone. So global healthcare market which are connected to IoT has been projected by 2030 $500 billion. So which is very important here. That means the market is going to project at that level. That is the trade of market. And just we can see that when we are looking the IoT ecosystem, then IoT ecosystem which are connected as per the various layer. That means we want to know the various wearable electronics because of the smart devices which has been implemented under the electronics field. That is very important because these devices are physical devices, physical objects which connected with various sensors, actuators, and various advanced microcontrollers with respect to medical devices. So what is the major functionality of these devices? That because the data which is captured from the physical world or real world, and in terms of heart rate, either by ECG or PR and other factors, and like glucose level, whatever the glucose level which we are extracted, and various other parameter which is collected from the temperature or many other points, like wearables devices which are connected through smart watches, ECG patches, and whatever the SPOT sensor. So why these completely systems are very important? Because I told in the previous slides, the global internet of medical things, the market size has reached to that 50 billion. Now it is going to reach to 2030 $500 billion US dollars. So market is projected to grow from USD that means 50 billion to 500 billion towards the that is the forecast period would be there. So we can say in terms of 5G, in terms of 6th generation technology, all these generation technology is very important because the wireless technology offering the significantly higher speeds, lower latency, reduce the delay, edge computing, greater network capacity as compared to 3G, 4G networks are there. So according to our system in IoT T. So that means the data which is extracted through various sensors like sweat sensors, temperature sensor, gait monitoring, or press or strain sensors, EMG sensors, ECG sensors, or EPG, or many other activity which are required, virtual reality or sleep monitoring. That means how much sleeps are there, augmented reality, virtual reality, all these are the major applications which has implemented already, but the function is to collect the raw data from this physical world, process them, and we can monitor continuously to the system. So connectivity is one of the requirement. So earlier days we were using IoT at the lower bandwidth level. Now we are looking for higher bandwidth level because data rate is increasing day by day. The processing requirement of the data is very important. So that means connectivity means we want to get the communication technologies. So communication technology is not correctly what we are using. It has already improved a lot. So devices are able to send the data and devices are able to receive the data with respect to short range wireless communication system, with respect to long range wireless communication system. So related to short range wireless communication system, we are using device to device communication through Bluetooth, through Zigbee, through Wi-Fi, through near far whatever the technology will be there. So we can get it the particular technology which are required here. So we have seen that lower range 4G, 5G, 6G, or LoRaWAN, or NB-IoT, satellite IoT, all these are the long range devices which we are using here. So Bluetooth, Zigbee, Wi-Fi, and near field communications are connected to internal devices which are very short range. So importance is here, we are going to collect the data with respect to choice of protocol, because choice of the protocol will decide what kind of power we can use, how much range we can use, how much latency we can use. All these are the major requirements. So this is the major important part, because if the device will not be able to communicate each other, we cannot manage. So we ensure that secure communications, we ensure that reliable data transfer between devices to cloud or devices to servers. That means data will be collected from the patient to doctor, patient to hospitals, which is very important here. So means after that the process will be sent to the cloud processing. That means the data processing will take place at the gateway level. Here the local notification will take place, protocol conversion will be there. So various protocol conversion process are needed here. Data need to be filtered and mining. So what is server? Server is the data platform where data will be stored. Various heavy storage memories are needed here. Data analytics are needed here. Decision making process will be handled at this level, and various medical interface are. So users which are taken care. So particularly where data storage and pre-processing and analytic functionality will happen. So here we can say the functionality is aggregate this all data, analyze this all healthcare data, and we need to run the various AI algorithm, machine learning, deep learning algorithm to identify the anomalies, to identify any abnormalities, and ensure that when we are going to handle this data for transfer or to receive from various sources, that compliance are very important, because we need to work on security standard. So various security standards are there which is available under the clinical side. So clinical side, the clinical domain people are going to analyze this HIPAA compliance, GPD, PR, and examples in terms of healthcare, because whatever the Amazon Web Services we are using for healthcare, Microsoft Azure IoT which we are using, Google Cloud Healthcare which we are using, and various hospitals, they are having their own servers for local data processing. That is also second important aspects for IoT ecosystem. That means connectivity, cloud and processing, either cloud processing or edge computing. So finally, these ecosystems will give the help to the applications point of view. That means how the systems are able to connect to the hospitals or connect to the doctors, connect to the particular patients, and finally the patients are insured. So insurance company, insurers are there. They want to connect this thing. So we want to provide the base interface. That means services that deliver the complete insight of patient, doctor, as well as hospital and so on. So what is the major functionality towards the application point of view? The present information is we want to enable the decision making capability at advanced level, and we need to alert or trigger alert to the particular to get the vital changes are coming in the parameter. So understanding of the data, which is very important, that the patients are in the bed and it is a smart bed, which we have seen that already it is collecting data and communicating to direct just hospitals, doctors, or other practitioners which we are working. So remotely the patient monitoring servers are working here, and data will be collected from these patients and extracted through sensors, transducers, which will be transferred to switch and then will transfer to the this server, and that server will just provide it available at the dashboard for remote staff. And the person is not available, that would be available through their phone, through their laptop, and whatever the gadgets are available. So in these applications there is a apps are available, mobile health apps are available, which are readily available for patient monitoring or medications reminders. And also we can observe the doctors which are using this data, how this data is available for them. So for them there are certain tablets are available which can easily dashboards will provide the real-time parameters. If any abnormality will come during the particular time, automatically there will be alert also would be provided. And telemedicine platform, that means the patient will not be able to come at the hospital. So that means video consultation also would be provided, that will be integrated continuously monitoring of the patient with integrated IoT data. And also we can see that patient will just visit to the hospital, it need to go for the admission. So at that time the patient will connect to the insurer, and that insurers will just provide the details which are the particular possibility the patient would be there. So insurance to claim it, and we can just go through this kind of applications only. So ecosystem will provide this application level, this applications layers are there. Now, who are the major stakeholder of the medical IoT? That means when we are looking for the patient, they are end user. That means patients will get the more benefit. They are the main stakeholder of the medical IoT. The role of the patient is primary users. They are wearing wearable devices. They are using various monitoring devices, and that main benefit will be given to them in terms of real-time healthcare tracking. So that means real time we can manage their heart rate, we can manage their blood pressure, we can manage their glucose, and also we can reduce the number of visits to the hospital. We can remotely monitor them, and personalized treatment medication reminder also would be given to the particular patient. So if they are going to just finish their medicines, it will be given, it will be provided medicine reminders, and will be provided the home services. So improve the engagement with respect to own healthcare. So like example, we have seen that in the research work, there is a diabetic patient, they are using continuously glucose monitoring, which is connected to mobile app. So continuously the data which is extracted to the patient, which is available in mobile app. If any abnormality will come, it can be alarmed to the doctor. So healthcare providers, doctors, they are using the IoT data from the diagnosis, from the lab diagnosis, or from the particularly data will be collected from the blood or from the various sources. So monitoring also would be very important. Treatment also would be important. So for the doctor, healthcare provider, main benefit is they can access the continuous patient data. That means the continuous patient data, which is very important, instead of occasional visit, instead of giving personal visit, so they can get the faster and more accurate decision making. That means the data which is extracted to the doctor immediately, data can be collected by the doctor from the patient, and it can easily access through the patient data by the doctor, which is very faster and more accurate, and decision making also will be provided very fast. And remote consultation, which we can just see that via telemedicine platform, and various chronic disease that can be analyzed in early cases. Early detections of health issues are very important. So here in this second part, the example, cardiologists monitor the patient ECG remotely. They are not going to connect to the different, and they detect the arrhythmias condition or various other ECG abnormality that can be analyzed. Now, after the patient stakeholder, doctor, the third is hospitals. They are major stakeholder in the market because they are providing services and they are using the various doctors or medical healthcare providers. So they want to integrate IoT devices into their own system because structure which will be created by the hospital. So that means they have to create smart healthcare equipment. That means smart hospital equipments are there, which is readily available at the hospital in terms of beds or infusion pumps or ventilators, and also they can provide the efficient asset tracking by using of RFID, near field communications, or they can track the wheelchairs or equipments, where the equipments is available, where the wheelchairs is available, and also reduce the administrative burden. That is the major important aspect here, automated record keeping. And also we can improve the major safety through real time. So example, a hospital bed detecting the patient moving when we are going to prevent the bed scores. And the last stakeholder is the insurers, that when they provide the health coverage and they are going to provide the claim processing only. So in current trends, people are mostly using the medical insurance because they want to access the real-time data for accurate risk assessment. That is the benefit. Fraud reductions also, they want to go for to verify IoT data, and they can also encourage of preventive care. That means whatever the preventive care was there, that means it can be encouraged and we can reduce the cost, which is readily available, economically available for the people. So insurance, they can provide the various discounts for the patients using various healthcare monitoring devices. So as per the requirement, when we see the benefits for the patients in the current trends, so what is the major benefits of the patient? We can get it personalized treatment because whatever the IoT devices which are using by us, we can track the individual health data continuously. We can provide the that is very easily can provide, adjust the doses automatically. That is the adaptive therapy will be there, and we can track the healthcare data continuously, as well as we can provide the personalized treatment to the patient. As a continuously, the monitoring also very important because real-time monitoring, especially for vital signs in terms of ECG or in terms of to compute the BP, glucose, SpO2, all are very important. And based on that, we can detect the early warning signs of health deterioration. So when the health deterioration will be there, under that early warning signs will be sent to the doctor or hospitals. And medication adherence is very important here because IoT will be involved with IoT enabled apps, and these apps are continuously sending the reminders for medication schedulers. So whatever the medication schedules are there, based on that they are sending the reminders. And doctor can also use the particular personalized treatment plan. What is the personalized treatment plans are there, where the visit will be required for the patient. Based on all these kind of aspect, that means patient specific data which will be collected and will give the general average. So we can reduce the dependency on hospital visits as well as enhance the peace of mind for the patients and family. And there is a very smart pillboxes are there. That means pillboxes will notify caregivers if those are missed or if the going to over, if the medicines are going to over, that kind of information will be provided. So this is the major benefit of the patients. Definitely the benefit will be the given to the patient. It will be the major benefit of the providers. So providers which are very important because doctors and hospitals are also part of healthcare field and they are main stakeholders. So real-time patient data would be very important for them because we want to access the continuous patient data. That means when we'll talk about that means continuous patient monitoring system. So continuous patient monitoring system will take the particularly continuous patient data, that is health data, instead of snapshots. That means occasional checkup there will be given for snapshot. So we can enable the data driven approach. Data that is the major important in the currently this data which is very important for various clinical decisions. So that means there are many clinical stages are happening for development of various medicines and many stages are there. So that will be very important. We can enable the data driven clinical decisions, and also remotely we can provide the consultations and telemedicine can active here. So doctor can easily monitor the patients from anywhere via for mobile phone, and it can improve the healthcare delivery in a rural area, in a different reserve areas. There, that means the doctor cannot reach. There is hospital, people are not able to provide the services there. And operational efficiency, which is very important because smart hospital devices, like we can get the beds became smart beds, infusion pumps, the smart infusion pumps, all these devices can reduce the manual processing. Manual workload also will reduce. Manpower also that can also reduce here. So we can help to early detections. In early stages, we can detect the disease. Also, complications also can be examined very easily, and we can detect the sepsis or heart failure at early stages only. And it can be rescue of the life of the people under certain cardiac arrest will be there. And IoT with AI integrations, which will be very important in telemedicine platform because we can get the real-time vitals parameter during the virtual consultation, and also we can predict the conditions of the patient also. And IoT enables set there we are using the tracking save time because we can track the particular where the equipments are available. We can locate the equipment. So this is the benefit of the particularly doctors and hospitals. Similarly, the benefit for the insurers, that means various pricing condition will be there. That means risk-based pricing. So insurance company will they will use health data with the help of IoT with respect to individual risk profiles. What is the we can they can calculate the what is the condition of the patient would be there. There we can encourage the preventive care or not. We can reduce the long-term treatment costs also. That means it does not require a long-term. They cannot bear that. Limitation in the insurance companies are there. That means sometimes people are sending the fraud bills. So for fraud reduction is very important for them. So IoT devices will provide the verifiable data, real-time data, actual data of the patient health. They can easily track them. It can improve the trust between insurers and providers and patients. And data-driven strategy is very important. By that way, they have designed the various policy. So policy design is very important because insurance company can customize the insurance plan. They can reduce the plan based on the what is the patient data patterns are there. Whether the patients are suffering frequently or very less. Based on that, they can maintain the healthy lifestyle with the IoT wearable device. And also sometimes the people who are using insurance plans and all, the benefit is fast claims can be reduced. Misuse of the health insurance benefit also, that also can be reduced here. Now, medical IoT device architecture. That means what is the complete systems are there. That means through the body area network. That means the device which is placed on the various body part. That means which are able to communicate each other. We can get the data through this device. That means whatever the edge computing or various device which are required, we can get it. So things which will be able to provide the data from various sensors. So that means that is very important. So here there is a cryptography mechanisms are very important because we want to authenticate the all these devices and data which is collected from this device. Then here the local area network, there is a device gateway will be there. Here we can provide the various edge computing devices. There we can solve the problems. That means we can see the wired devices, wireless devices, PAN, LAN, all these devices are available here. So sensing unit, which is very important here because various grade sensors are there, medical grade sensors are there, ECG, SpO2, or temperature, glucose. And processing unit is also which will be connected sensors to the microcontroller or various device boards, so which are consist of ARM, Cortex, Arduino, ESP32 or system on chip that is required for processing of this data. Then communication module, which is very important because without communication data cannot be utilized. So Wi-Fi, BLE or Zigbee, LTE network, 5G, NB-IoT or 6G. So many communication modules are important here, which are able to collect the data, analyze the data, transfer the data. And cloud, that means data will be stored at that level, data storage and various AI/ML analysis will work here. By using of analysis, we are going to analyze the anomalies in the data and also electronic medical record system. That means it will generate the electronic health record and will be printed in terms of history or particulars details health record of the patient. That means electronic health record which will be provided in the emergency conditions also. So last stage, that is the back end data sharing. Under that, we can see the remotely the people are sending data that will be available on the server, and then we can add the AI analytics and generate the electronic health record. So discharge summary will be available at the patient level only. So sensors which are very important in healthcare, that means we are using various sensors. That means normally various important sensors which are available like ECG sensors which are required to monitor the cardiac part of the body. That means you can measure the electrical activity of the heart. We are using the various cardiac monitoring system, arrhythmia detections, easy load analysis, smart patches which are available. So we are using the electrodes. We can place the electrode near to the heart and we can measure the electrical activity of the heart, because by that way we can monitor the cardiac condition. So cardiac monitoring will take place, arrhythmia detection will be very important, smart patches will be very important. Like other sensor, SpO2 sensors that is considered under the pulse proximity sensor. By that way we can measure the whatever the blood oxygen saturation of the body part would be there, pulse rate would be there. And essential during the COVID time, we have monitored the SpO2 to maintain the life of the people. Also, we have seen that respiratory illness condition. Under the respiratory illness condition, this data can be collected. ICUs, the data is continuously monitoring. Glucose sensor. So we can continuously glucose monitoring will take place via particular sub-nation sensors are there. So connected to mobile app. That means mobile app, through that we can get it how many sensors are connected, what the data has been extracted specific for chronic disease like diabetic or heart disease are there. And BP sensors. So BP sensors we can find out the toughness, we can find out the wearness, wearable BP monitoring devices, as well as we can track the hypertension trend. Whatever the hypertension trends are there, we can track them, and also we can provide the medication effectiveness. Whatever the medication effectiveness are required, which can be aided through this blood pressure sensors are available. So we want to get these details, Holter monitor with ECG reading. So ECG reading showing the heart rhythm. So particular Holter monitor also there, which are readily available, and various other devices which can be used to get the pulse details of the patient, or particular whatever the blood pressure part would be available. So various sensors which are available. After that, the data which is collected through sensors, it will pass through a data agreement system. Data agreement system which take the data from the sensors in terms of analog, and then it will transform into digital. And also there is a possibility which is data will be collected from various sensors while sensing or while equations. There is a very important part here. So data agreement system, the main process of to capture the physiological signal, physiological informations from the sensors and preparing them for pre-process. That means we want to get this data from electromyogram, muscle signal, which will be extracted to the EMG sensors, then power line interferences, and then we can apply the removal of various artifacts. Then after that, denoising part would be very important. We need to get the convert the raw biological data which is extracted from ECG, BP, SpO2 into digital signal. So we need to apply sampling and quantization based on the resolution. So 8-bit resolution, 16-bit, 32-bit resolutions are there. It will determine the accuracy. And after that, noise filtering is very important, because we have seen that noise will involve under the channel. So we need to see that motion artifacts would be there, power line interferences will be there, EMG noise will be there. So by using of various filtering, so filtering at hardware level, we are going to apply low pass filter, high pass filter, band pass, and filter at low at the software level. We can get it digital FIR filter, IR filter, and adaptive filtering. So we can ensure that when we are using the signal which is extracted from various sensor, ensure that it must be clean and reliable medical data. By that way only we are able to provide the diagnosis. So after that, processing units, the data extracted, converted to digital, then processed by the particular microcontroller unit, and that would be very important, because we are going to perform here as a computation, and we are going to perform here communication. So microcontroller units, earlier days we were using 8051 and various other AVR based microcontroller. Now we have completely replaced low power microcontroller, that is ARM based microcontroller, ESP sensor interfacing. Here sensor interfacing we can easily handle, data equation we can easily handle, wireless communication we can easily handle. So we know that microcontroller consists of on-chip RAM, on-chip ROM, on-chip timers, interrupt controls, on-chip serial communications, bus control, and there is a frequency will be required to provide through the oscillator. So system on chip processor which has been designed in currently like Raspberry Pi, Jetson Nano, Jetson Orion, Jetson TX2, TX1, and Qualcomm has implemented Qualcomm Snapdragon processor. So more powerful implementation took place from the 5 year with respect to SoC and processing side, and all these boards and processors are supporting to AI interference. That means whatever the AI ML interference that require, when we'll get the multi-model sensor data, and this multi-model fusion is very important. So after that, the system will communicate to the FPGAs boards. So custom parallel computing is very important here. So there is a parallel processing part which is required for high-speed medical signal analysis, and these are used in real-time ECG classification. That means when we want to use ECG classification, when we want to arrhythmia classification, arrhythmia detections, MRI image reconstruction, CT scan reconstruction, all these kind of applications which we can do with the help of FPGA. Now, edge computing. That means when we'll see that devices which are available here, and we are going to provide the edge devices, which is very near to source. So edge computing means processing the data near to source only. That means near to device or gateway. Instead of data would be processing at cloud. So sending everything to the cloud does not require, because why it is very important, because we can reduce the latency. It will work. We can provide the privacy with respect to sensitive parallel data. That means whatever the parallel patient data will be there, still will become low, and we can reduce the bandwidth. We can improve the, when we want to send the essential data to the cloud, we'll do it only. And based on that, reliability works. That is very important. So works even if connected systems are failed. That is the major portion. So applications, we can use the anomaly detection in ECG. It can be locally provided, and on devices glucose monitoring would be very important. That trend also would be very important. Smart inhalers are there. By that way, we are going to analyze the respiratory rate form. Connected module, that is the communication modules, which are very important because we are using the Bluetooth low energy. It's a low power, work under the short range. Variable sensors, which is connected to Bluetooth, fitness band, which is connected to Bluetooth, smart patches. So variable patches which are available with LED technology, camera which are available with receive the monitor data in terms of face or with respect to facial data. Microcontroller will process the data as a computing unit, and like that we are going to provide the whatever the systems are available. That means networks are available, core network, and then it will be provided to monitoring devices at the hospital level. That is the core network which is required high mega bandwidth services. So mega bandwidth services which will be given at this level only. So whatever though this OC system inside the ambulance was there, it must work when we have the this kind of technology. BLE would be there, Wi-Fi will be there, cellular would be there, because cellular will provide the wide range mobility, ambulance telemedicine, rural pressure monitoring. As if Wi-Fi high home health monitoring system related to 5G and 6G, will see the low ultra latency, real time surgery assistant, augmented reality, virtual reality would be added in the healthcare domain, which is large IoT deployment. And power management, because we want to know that when we are looking, many devices will be connected, automatically the power concern will come. So many medical devices like wearable sensors, implants, remote monitoring, they must operate for day to month without any frequency charge. So power efficiency, which can be easily handled for the impact of usability and patient comfort. So with various techniques will be utilized here. Low power hardware we are using, like we are going to control by the various microcontroller, like microcontroller related to ARM, Cortex M, RISC-V, and energy efficient sensors are there, radios are there. Finally, data cycling. That means we are going to turn off the modules when we are not using. As well as we are going to provide the Bluetooth low energy system that accessing only periodically. The energy harvesting also will improve here through the various renewable energy resources like solar, kinetic, and thermal, body heat or body motions in terms of energy, and is extend the battery life in variable services. So similarly, smart battery management system, which is very important for monitoring the charging and discharging, also very important for prevent the overheating, ensure the safety in implants. So battery management. After that, power management will go for the device processing. That means signal cleaning. So data which will be extracted from the sensor, it's a raw data. Then we are going to clean the data, remove the noise, and we can go for the event detections. Event detection will take place feature has been extracted, and we'll feed this feature to the classifier, which is available at analytical level. Analytical level, they must know about volume, shape, and dipole and charge. Various things are there which can be identified. So device processing, initial data cleaning before transmissions, and after that It's ensure that it will be useful, reliable, and compressed data which is sent to the cloud only. So here the steps will require when we are going to clean the data. That means noise removal. At the noise removal point of view, we are going to filter or denoising of electrocardic signal or electroencephalogram signals. Whereas main benefit will be the baseline drift and motion artifacts that can be eliminated, and it work as an adaptive filtering level and wavelet transform. Then after we know that when we are talking about machine learning, we are going to extract the feature. That means that era of feature extraction will start here. So extracting the various features from heart rate variability, from SpO2, from the glucose, or various trends are there rather than only waveforms are collected. And we can reduce the bandwidth, storage, and latency. As well as we can improve the compression. So data compression also would be reduced because we are looking at the biomedical level, lossless technology. Lossless technology which will be utilized Huffman or relevant encoding would be there, or quantization based lossy techniques which sometimes can be utilized. So optimizations for low power devices very important. Event detection. So various event can be detected. Local event it will be detected. Various anomaly will be identified related to arrhythmia and hypoglycemia. Or only we can send that alert only when it is necessary. So we can provide the alert to the particular caretaker as well as the hospital or doctor. Related to that part will come under the pre-processing at the signal cleaning level, signal processing level. Now we'll go for the final talk like edge computing and cloud computing. So we know that the sources which is available near to the, that means which are source, that means devices which are available near to the sources which is collected data as real time. So hybrid approach will be utilized here when some processing happens like locally on the edge devices. When we go for the more complex analytics and storage that occur in the cloud. So we can say this is the data collection stage where the electricity consumption will work, where occupancy patterns are there, temperature, humidity, all. Here at that level, edge level, this computing is has become near to the edge layer. So here data reprocessing, data cleaning, data resampling, micro moment extractions at the local data store also would be there by the edge gateway. And then finally, we want to provide the business level at the cloud, so applications for anomaly detections or analytic visualization, security, analytic dashboard, all this kind of thing would be added at the using AI. So data storage is very important because data will be collected from device and we want to send to the cloud. So we want to easily manage and backup and secure the data. So enable the various big data analytics at this large patient population. And this would be the pros. And what is the cons? What are the cons of the storage part would be there? That means we are not getting perfect latency. We want network latency. It should not be go for single point of failure, and privacy concern very important. So this is the major important part at the cloud is good. But once we include edge or federated learning, data will stored at many devices. Many get the data availability and fault tolerance, provide the privacy since data can remain on local device only. And we are going to provide the federated learning, that means AI model trained on distributed data without sharing of raw patient data. So it is very hard to synchronize them and manage them, and limited resources which are available edge as compared to cloud only. So we can say that what is the role of communication in medical Internet of Things? Communication will be the backbone of medical IoT, MIoT, because it provides the seamless data transfer between devices, between patients and healthcare domain. Without reliable communication, MIoT device cannot be delivered timely insight. So data transmissions from the various physiological data from the sensors to the gateway, and then real-time monitoring. We can ensure that doctors and whatever the caregivers, patients are available, they will provide the healthy update, critical for emergency alerts, for the specific for cardiac arrest and all. Interoperability, that means standardized communication system need to be allowed for the devices. from different vendors to work together. Scalability is very important because we are going to support millions of devices in hospitals, homes, and remote areas. And also security and privacy concerns. So related to that, secure channels protect the sensitive health data from breaches are there. So various communication protocols which are required in medical internet of things like short range protocol, which is available at variable and home care level, like Bluetooth low energy. It is available low power, ideal for variable sensors. Zigbee it is also used for networking for hospital equipment. Wi-Fi, which is require high bandwidth, used in smart hospitals. Near field communications, which are very important with short range only for patient authentications and data transfer. For the long, because we are using 4G, 5G, 6G or LTE networks which are required for wide range supports. So we want more coverage. We want to provide the support from mobile patients and telemedicine. So LoRaWAN will be there because LoRa is support low power, long range are useful in urban, rural healthcare monitoring. So rural area which we are going to use such kind of protocols, and we narrowband IoT which is required for low power, low range medical sensors. And at the end, data application level layer protocol will be utilized like MQTT protocol for lightweight for transporting patients data, and constrained application protocol, low power devices can be designed. HTTP protocol, web based medical apps are available, dashboards are available. HL7 are there, healthcare standards which are ensure that interoperability with respect to hospital information systems are there. That means we can manage electronic health record, electronic medical records are available. So short range protocol, which we have seen that we are using the typically low power, low latency. So BLEs are there, Zigbees are there, NFCs are there, RFID, which we are using asset and patient tracking, Wi-Fi also there. Short range communication protocol, which is required for device to device communication. Directly we can within the few meters only. For the BLE, it became very popular because it is designed for variable sensors only. Range is very low, 10 to 30 meters. Data rate is also 2 Mbps and has designed for smartwatches, for specific for heart rate, SpO2 monitoring, continuously glucose monitoring, ECG monitoring. Main advantage, energy efficient and less battery, that means month of battery life is more, and widely supported in smartphone. Similarly, Zigbee, which are required in hospitals, that means it's low power, relay data range is 10 to 100 meter per node. In the smart hospital rooms, which are working in the beds, monitors, pumps, medical equipments, which can be tracked, or various wireless nurse call system. So major advantage, many devices can communicate simultaneously in low power bandwidth as compared to Wi-Fi. The near field communications in medical devices, with very short range devices, it's provide under ultra low power, often passive, because no battery needed here. So this is required for patient identifications, secure device pairing, or particular medication tracking. So advantage here, security would be very important. So secure because of low range communication. It is very simple, and not to continuous monitoring. That is major challenge here. So RFIDs mostly which are using in hospitals like a band, which are using radio frequencies, few centimeters to several meters are there. Main application is we are tracking the patient, we are tracking devices through RFID. Asset management also, we can provide the inventory management like blood bags or surgical tools. Major advantage, enhance the hospital efficiency, reduce the human error in patients asset. Also privacy concern, which will be very important here, because patient data which will available in tags and electromagnetic spectrum interference will be there. So Wi-Fi also very important in communication protocol because provide high bandwidth, wide availability. Range is 50 to 100 meter indoors. Data rate has reached to 100 Mbps to several Gbps when we are using the various protocols. So telemedicine with respect to video consultation would be aided by this Wi-Fi, connecting bedsides monitor to control the hospital servers, and various smart hospital system like can be provided robotics, smart beds, imaging, and high So because this system is completely power hungry, no ideal for variables. So security risk if networks are encrypted. So long range protocols, that means that is available wide area connectivity under that. So we can enable through the long range protocol like telemedicine, rural health services, ambulance to hospital link support for remote monitoring. So cellular 4G, 5G, which is available high bandwidth, real time telemedicine, LoRaWAN, or narrowband IoT, satellite IoT. So in cellular 4G and 5G, we can see here smart healthcare, wearable devices are connected with medical devices. 5G will help them to remote diagnosis, will help transportation. So live video consultation we can do, remote IC monitoring we can do, ambulance to hospital patient data transfer. So high speed and reliable, that is the major concern here because it support to HD video and real-time control, global coverage would be there. And main challenge is high power consumptions because many devices are there. Network cost also increase, availability in rural area will be very important. So LoRaWAN we can see here that is the range from 15 to 20 kilometer rural area, low power and long battery life will be there. So low data rate would be there like 0.50 kbps. That is not suitable for high data rate like MRI images or video. It's affordable for low power for a rural area, remote area only, and work under the cellular coverage is poor when that possible. So village health monitoring, that means transmitting the patient data, vital data only to the city hospital and connecting the rural clinics and rural hospitals for regional health hubs only. So we can track the various vaccines and medicines in remote supply chain. So support varies by region. So related to IoT now satellite, which has uses LEO, MEO, GEO satellites for connectivity, that means space segments, user segments, and these are the ground segments and ground communication network. So disaster relief, healthcare area can be provided if they destroy the infrastructure. So ambulance, ships and aircraft, emergency telemedicine are the applications, remote diagnostic in deserts area, mountains area, and main advantage is coverage is everywhere in the world. So vital is disaster zone and military healthcare. So mainly the challenge of the satellite IoT in emergency, expensive bandwidth, higher latency as compared to 5. So protocol stacks, which we have observed that in OSI communication module. So there are different layers are there. Here layer, physical layer, data link layer, transport, session, presentation. But in the IoT, which will be available, uh, perce- perception layer, connected at sensors, network layer, transport layer will provide the protocol, TCP, IP, and UDP. Application layer will provide the protocol like MQTT protocol and FHIR. So key point, IoT required lightweight. So low power protocols are required for constrained devices. So basically, we'll compare that MQTT protocol, variable alerts, lightweight, and need for security. Limited QoS, heavy for IoT. Similarly, for other protocol, you can say it's a widely adopted and friendly, cloud ready, universal imaging. So we can say the why security is very important in MIoT because patient safety is very important. We cannot compromise the devices. Could at particular and in their lives and sensitive data because medical records are very highly confidential and it's available. It's very important. Weak devices. So many devices have limited memory and trust is adoption is very important because strong security trust is there in patient, doctor, and regulators. So various compliance are there because Digital Personal Data Protection Act has designed 23, that is DPDP Act, Digital Personal Data Protection Act, and Draft Digital Information Security Healthcare Act, or with Ayushman Bharat Digital Mission Act. So it's framework for electronic health record. This is specific for healthy data privacy. It is designed for require consent-based data uses. So these are the common trends in MIoT will be there. That means whatever the malware and other conditions will be the types of cyber attacks. So data tampering is very frequently happening, because alert the medical readings, denial of services, or insider threats like unauthorized staff misusing the patient data, malware or ransomware that will disrupt the hospital systems, log the patient data, device hijacking like they control the critical medical equipment, or dropping. So erase dropping means hackers will intercept the encrypted medical data. So authentication mechanism is very important, like password, biometric, two-phase factor authentications by password plus OTP, or OpenID Connect device. So encryption is very important because at the rest and transmit, both store and transmit data must be protected. We can get the data, we can encrypt them, and then we can reconstruct them. So various techniques which we have seen that in particular encryption technology like AES, DES, RSA, these are the algorithms are there. TLS, SSL, security transport for MQTT, CIP protocol, homomorphic encryptions. So we can use various technologies decentralized and tamper-proof the conditions which are required. So like we see the patients or healthcare safety authority would be there. These are the devices are there monitoring which we are going to do. So related to first registration, then send the credentials, then we can go for the device properties, then particular send the transactions for the registered device to change, then device need to be verified, and then device verified, then go for the particular monitoring, then send the input data, then particularly send the transaction with encrypted data, and then these are the mining parts. So application, patient control, data sharing, drug supply chain verifications. So major advantage of here is transparency, integrity, and accountability. And related to IoT in emergency response, because when we want to apply real-time ambulance for particularly hospital data transfer. So IoT sensors are available in ambulances to track this data continuously, that feed the hospital dashboards and enable the electronic records. The team to prepare the equipment, everything will be ready. So disaster relief, healthcare also, various drones are working, deliver the medical supplies in a food or in a flood or whatever the earthquake zones are there. So satellite IoT will ensure that connectivity the networks are down, and wearable devices are very important. Real-time patient support will be there. So smart implants or whatever the prosthetic systems we are using, like these are the smart implants with the integrated electronics, implantable electronic we are using. Also smart pacemakers transmit the heart data to cardiologists. Also brain computer interface technology which are ready to use for neurological rehabilitations. And IoT, because prosthetic systems which are using with IoT sensors grip the strength and gait and balance, and AI and IoT will connect with provide the feedback loop to improve the patient mobility and safety. So related to IoT in mental health monitoring system, because we can say wearable IoT sensors that track the heart rate variability, sleep cycle, skin conductance, and detect the early signs whether a person is suffering from anxiety, depression, or various AI-driven insights are there. That means machine learning algorithms are analyze the long-term mood patterns, real-time alerts for patients or caregivers, or virtual therapy would be provided. And also IoT for elderly assisted living, which we are going to use for fall detection system. That means these are the devices continuing monitoring to the elderly people. That means smart variable and home sensor detect the sudden falls, auto alerts sent to the caregivers or emergency services, smart home integration. So that means various IoT systems are there for medication reminders, smart beds are there, or vital sensors monitors are there, or particular we can get the independent living with safety net for this thing. And now IoT which will be connected to digital twins, that means where virtual replicas are available for the patient's organ. So when we are talking about real-time data that feed to digital twin model, doctor can simulate the disease on the surgery on the outcome, and this they can plan for surgery. They can treatment planning. So personalized therapy, that means digital heart twin for pacemaker calibration, reduce the trial and error in medical intervention, and provide the better predictions of the post-surgery complications. So IoT in genomics and precision medicines, that means various biomarker collections with respect to variable track and environment, lifestyle of data affecting the genes, as well as continuously glucose, sleep, stress monitoring also that can be enrich the genetic data set. So personalized drug responses, because when we are talking about IoT devices that measure the individual response to the treatments, and also we can get it the dynamic dosing or targeted therapy. So also we can fill that the gap between the genomic research and everyday what patients cares are there. So these are the major cost benefit analysis for medical IoT. Hospital ROI will change because smart asset tracking save the staff time, reduce the losses, insurance adoptions are there, overall benefit, long-term cost saving in initial infrastructure investment. So various devices which are available like Philip remote cardiac monitoring system, based on that deploy for IoT enable ECG patches and cloud analytic platform, 20% reduction in 30-day read sense, and faster arrhythmia detections are there. And also for this Narayana Health RPM for heart patients, they design the chronic cardiac patients in rural India cannot afford the frequent hospital visit, leading to delayed the care. So in that case, they have reduced 30% fewer unnecessary hospital visits. IoT health devices are there, GSM connectivity, and whatever the medications are they use to improve the 25% due to the remote. Same Apollo telehealth services readily available in remote villages in India, like access to specialized doctors, cardiologists or neurologists. So they 4 million plus techno consultation completed. Travel costs also reduced by 60%. Early detection of hypertension and diabetic in unreserved communities are there. So data collected to the consultation via video and integrated with electronic health record for content. So IoT diagnostic kits, cloud health platform, these are the technology they use. So particularly Apollo has set up the telemedicine kiosk with IoT diagnostic services. So that is the another Mercy virtual care centers. There is rural hospital around 224/7 their access. These hospitals staffed by remote doctors and nurses and specialists. They are monitoring the patient real time via dashboards only. 35% reductions in hospital admissions, improve the management and chronic diseases, and reduce the patient receive the specialist level care without travel. So like that, feedback, one more diabetic and lifestyle management system has been developed that patient require the strict monitoring of activity, sleep, and heart rate for preventions. Patients show that 50% better medication adherence only. So according to that, various technical and ethical challenges are there. Remote cardiac monitoring, that is IoT enable easy patches are developed. Main challenges are here technically because network is missing the ECG alerts, battery may be drained, or patients felt over the monitoring 24/7. So likewise, various trends are there when we can use digital twin for personalized cancer care, and regulatory security challenge for IoT-based insulin pumps. And this is the Google Smart Vitals during the COVID-19 affordable and scalable monitoring solutions for home quarantine patients, which I solved. So technically, the major challenges in the domain is interoperability issues, scalability, battery and energy constraints, latency, reliability, as well as cyber security weakness. All these are the challenges which can be resolved. So ethical challenges are very important because patient's consent is very important, privacy consent very important, digital divides, human oversight. These are the ethical challenges are there. In future, the technology will connect to AI plus IoT, AIoT. That means detect the heart failure in right time, age AI for process the data locally, personalize healthcare, learn the patient history, and robotic surgery, that assisted robotic system connected to via IoT sensors. So Google AI, which you are using, enable the diabetic retinopathy screening with integrated IoT cameras. So once future technology will grow like 6G, so ultra latency will help in terms of various domain, massive device connectivity, high security, reliability, holographic telepresence. So all remote robotic surgeries with 6G enabled will tactile internet would be there. So these are the 6G technologies which are important for mobile edge computing, for unmanned aerial vehicle, quantum communication, blockchain. All this will be utilized in the future. So, thank you for. That's all from my side. Any queries from the participants?
Professor?
Yes, sir. Any queries?
Professor, am I audible?
Yes, sir.
Yes, Professor. Thank you for the wonderful session. We have actually seen the session in YouTube. Am I audible, sir?
Yes, sir. Audible, sir.
Yes, we have actually seen the session in YouTube, and we could see like lot of comments about your session. Everybody is saying it's an informative and interesting session. So hope we have another session also with you. So participants really benefited from your session. Thank you, Professor, for your valuable time. And most of the participants are asking about your presentation. So
Yeah, sure, sir. I will transfer, sir. I will mail to you.
thank you, Professor. And we are
Thank you,
also
sir.
looking forward for another informative session from you.
Thank you, sir.
Thank you
Thank you.
so much for your time.
Thank you, sir. Thank you.
We can close the session. Okay,
Yes.
thank you.
Thank you.
Yeah.